from chapter 4 to the following chapters, we will deal with 4 different kind of forces. So in this course, we will deal with 4 types of forces, external forces. Very, very important, okay? So chapter 4 is about the axial load. Chapter 5 is about the torsion. And chapter 6, chapter 6 is about the bending, and chapter 7 is about the shear, okay? So the next, including this chapter and the following chapters, we will learn about the 4, the 4 different external force. Again, force is a cause of deformation. So then different types of forces cause a different type of deformation, okay? Very, intuitive. So then axial load is symbolized as an N, torsion is T, bending is M, shear is V. And then this axial load can be converted to the stress, right? So then we learned already that there are 2 types of stresses. What are those? Can you please answer in the chat box? Normal and shear, absolutely, shear and normal, great. So the normal stress is sigma, shear stress is a tau, right? So then now we have 4 different types of external forces and create the internal force, which is sigma and tau, okay? Then can you guess that what type of stress the axial force creates? What type of stress is caused by the axial? Victoria answered normal, right? Normal. Austin says, yeah, you guys are correct. Axial force, so then the direction is very important, and then the section, cross section is important. So then axial load is, you can think about the column or the bar, pressing the axial load, right? What happens? It shrink or it will shrink, right? And then cross section is, we can cut the cross section, and then direction of the stress is normal to the cross section, correct? That's why axial force create the sigma, okay? On the other hand, torsion create, the, twisting, right? So then it will twist it, so it create a rotational deformation. And then if you cut the, the cross section, then the stress direction is in plane. So when you have an in plane stress, what type of stress you're gonna get due to the torsion? What type of stress you're gonna get due to shear, right? Absolutely. So then if this is a normal or if this is a shear, you want to think about what is the cross section and then what is the direction of the stress, okay? That is a very important thing, okay? So as you can see here, axial loads create a, normal stress. Torsion create shear stress. Bending create the normal stress. Shear create the shear stress. So in this course, as I said, I'm keep repeating because this is very important. we're gonna learn the 4 different types of forces, external forces, and those forces created, 2 types of stress, sigma and tau, and depending on which type of force, we have 4 different stress formula, which is very, very important. So I think what I wrote here is I can say the half of this course, okay? What is the other half? Obviously, the deformation due to this, right? Due to these stresses. So what I wrote here is, half of the, this course material. And there are also, some other things we can discuss about this. So then we have axial torsion. Oh, by the way, I will actually ask this. I don't require for you to memorize this, formula, but if you can memorize, and then it will be great, because you can save a lot of time. But this formula will be given in the formula sheet during the exam. Okay. And so axial force. So then in our learning objective, we also one of the important concepts is a member, right? So we have a structural member or mechanical member, and then we have a member. And what type? Can you give me an example of the mechanical member subjected to the axial load? What kind of mechanical member you can see in your around you? So what kind of a mechanical member? 2 forces. So the mechanical member is a structure or body. Okay. So then I'm asking that, for example, if you think about the building, and then building can be, building is a combination of all different kind of members. So building has a slab, or building has a column, building has beams and foundation and so on. So what would be the the structural member subjected to the axial load? Column, absolutely. Yeah, column is a very good example. So then in this chapter 4, we're gonna learn column line structure member. Very simple. But column is usually under compression, right? But there are also the member subject to the tensions. So we're gonna learn about that. What about torsion? Any example? What would be the example under torsion? If you think about, for example, car, axles, right? Shaft, axles. Those are the very good examples of, torsion. So we're gonna, in chapter 5, we're gonna learn about that, okay? How about bending? Bending. Truss, Gabriel, are you sure about that? Horizontal beams, okay. Those are, yeah, that is correct. So beam is a very good example of the bending. I want to actually go back to the Gabriel's answer, the truss. Truss, if you remember that truss, I'm saying about the ideal truss. So truss is the member connected with the bars, right? The pins, right? So then having that pin, we actually make all the stress, all the forces to be an actual force. That is the definition of ideal trust. So trust is belong to actual member, but trust is more like a structure rather than member. Okay, trust is a combination of a bunch of actual members. Okay, so then you want to distinguish the structure from the members. Okay, so structure is a combination of members. So then back to the bending. So then the beams are a very good example of the bending force, but the beam carries not only the bending but also shear force. Get it right. So then the beam carries both bending and shear. So unlike the other two types of the members, the beam is more complicated because it actually carries two different type of forces. So that's why we actually devote more chapters to learn beam-like structures or members. Okay, so this is a chapter 4, 5, and 6 and 7. So then 6 and 7 we're gonna learn that, and we will have a separate chapter for the beam deformation. It is called the deflection. So then that is the 3 chapters is devoted to the beam-like members.